Let's try to understand the azeotrops, student. We are going to understand what are the azeotrops. Some liquids are mixing to form azeotrops, which are binary solutions, binary mixtures having the same composition in liquid as well as in vapor phases and boil at the constant temperature. This is what is called azeotropic mixture. So binary solution, okay student, binary solution in which the components boil at constant temperature is called azeotrops. They have, if you talk about, they have the same composition in vapor and liquid phase, student. In such cases, it is not possible to separate the component by fractional distillation. It is not possible to separate the component by fractional distillation. There are two types of azeotrops called the minimum boiling azeotrops and maximum boiling azeotrops. These are two. The solution which show large positive deviation from Raoult's law form minimum boiling azeotrops at specific compositions. For example, ethanol and water mixtures obtained by fermentation of sugars on fractional distillation give solution containing approximately 95% volume by ethanol, that is 95% ethanol and 5% water. So they are going to boil at the same temperature. Now, once this composition known as azeotropic composition has been achieved, the liquid and vapor have the same composition and no further separation occurs. Now the second point, the solution that show large negative deviation from Raoult's law from the maximum boiling azeotrops at a specific composition. Nitric acid and water is an example of this case of azeotrop. This azeotrops has the approximate composition of 68% nitric acid, 32% water by mass, with the boiling point 393.5 Kelvin. So these are the azeotrops, student. So if you are talking about azeotrops, student, so that is they are the constant boiling mixture, constant boiling mixture, right? Boiling mixture. Now you keep in mind, student, they are formed by, how they are going to be formed, student? From non-ideal, from non-ideal solution. This is also going to be from non-ideal. This is what is the reason of non-ideal solution. So if it is showing the negative deviation means what, student? Boil at, negative deviation means boil at high temperature, boil at high temperature. So this is what the, if anything is showing negative temperature means negative deviation means you need to boil more. So this is what is the need to boil more means what is maximum boiling azeotrops. This is going to be maximum boiling azeotrops because you need to heat this one. Not ideal solution, positive deviation. It is going to a positive deviation. It means more vapor pressure are already coming. So boil at low temperature. Boil at low temperature. This is called low temperature. If it is boiling at low temperature, it means minimum boiling azeotrope, student. Minimum boiling azeotrope. So this is, you need to keep in mind, student, minimum boiling azeotrope. AZEOTROPES. So this is all about the answer, student. Thank you so much for watching.